In this section, we're going to take our application one step further. So we're going to build forms to add and edit customers and movies. So let's get started. We'll simply render the closing HTML tag. Okay, so this is our form. Now there is a special markup that we need to follow to render modern and responsive forms. And this is the markup that Bootstrap understands. So we wrap each input field in a div with the class form-group. Now inside this div, we need two elements, a label and an input field. We can either write raw HTML here, like label, or we can use html.label_for method. And here we pass a lambda expression that specifies the name of the target property in the model used in this form. Well, we haven't set the model yet, so let's go to top of the view and use the model directive. The model for this view should be a customer. So customer. Now back here, we use the lambda expression. M as in model goes to m.name. So when Razor View Engine renders this view, it will look at this name property and use this as the value for our HTML label. Next, we need a text box. Again, we can use raw HTML or use html.textbox for m goes to m.name. Pretty simple. Now let's run the application and see what we get before we add more fields to this form. So Control F5. Okay, right-click this field, inspect. Look at this input element. You see a bunch of attributes prefixed with data-val. For example, we've got data-val equals true, which means that we need validation for this field. We have another one, data-val-length, with a message saying the field name must be a string with a maximum length of 255 characters. Where is this coming from? Well, here's the definition of our customer class. Earlier, we applied two data annotations, required and string length, on the name property. So when you use the helper method textbox for ASP.NET MVC automatically supports validation for that field. In contrast, if you use raw HTML, you have to write all this by hand. Now back here, as the second argument to this method, we can pass an anonymous object, and any properties we add to this object will be rendered as HTML attributes. So if I want to give this element a class, I can type class here. Now you see there's an error here because class is a reserved keyword. So we need to prefix it with an @ sign. Now I'm going to give this the class form-control. This is one of the classes defined in Bootstrap that gives our input fields a modern look and feel. Let's save this view. Back to the browser. Refresh. Look, we get this nice hover effect and our text box looks a little bit chunky with round corners. So every input field we add to the form, we give it this form-control class. Now let's select this form group, duplicate it, and this time change name to birth date. So that's the label. We should also change the property for the text box, birth date. Now select again, duplicate. This time I want to add a checkbox. So label for is subscribed to newsletter. And here, instead of using text box 4, I'm going to use checkbox 4. And change the property to is subscribed to newsletter. Save. Back to the browser. Refresh. Okay, we have this weird layout here. Because when rendering a checkbox, we need to follow a slightly different markup. Let's go to getbootstrap.com. Under CSS, scroll down. Here you can see forms. Scroll down. So this is a Bootstrap form, and here's the markup. If you scroll down a little bit more, this is the declaration of our checkbox, which is different from other fields. Because with other fields, we need to enclose them with a div with the class form-group. And inside each form group, we have a label and an input field. So I'm going to grab this markup for the checkbox, copy, back to Visual Studio, paste it here. So we have a div with the class checkbox. Inside this div, we have a label, and inside the label, we have our input field. Note that this input field does not have the class form-control. So I'm going to replace this with html.checkbox4. M goes to m.is subscribed to newsletter. And then instead of using html.label4, I manually type the label for this checkbox. So subscribe to a newsletter with a question mark. Now we can get rid of this form group. Save, back to the browser, refresh, problem solved. Okay, so this is our form. Now, you can see that with the name and birthday fields, the name of the label is exactly the same as the corresponding property in the customer class. What if here, instead of birth date, I wanted to display date of birth? Well, here we have two options. One is to go in the customer class and apply a data annotation to birth date called display and set its name property to date of birth. Let's compile, back to the browser, refresh. So it's changed. But the problem with this approach is that every time we want to change a label, we have to recompile our code. An alternative approach is to go back to our view, and instead of using this label for, you can manually add a label like this. Now, before saving this, let me show you something. Back to the browser. If I click on the label, the text box below it gets focus. This is because we have an attribute on this label called for. So label for birth date. And birth date you see here is the ID of our input field. Now back to the view. If I remove this label for and use my raw label element, save, back to the browser, refresh. Now this time, if I click this, you see the text box does not get focus. So if you want to get the focus behavior, you need to go back here and manually add for and specify the ID of the input field, which is birth date. Now there's a different problem with this approach. If I change this birth date property in my C# code, it will not be updated here. So you can see we don't have an ideal way to render labels. You either use raw HTML and have to manually specify the name of the target property like here, but this comes with the risk that if you rename these properties in your C# code, you will have to come back here and manually fix them. In contrast, when using html.label4, because we are using a lambda expression, if I rename birth date in my C# code, it will get updated here automatically. But the problem with this approach is that if you want to change the label, we have to go back here and apply this data annotation. So I leave it up to you to decide which approach you prefer. But I personally prefer to use this helper method. So let's get rid of this. Okay, now I want to add a drop-down list to select the membership type for this customer. So back in our controller, in the new action, first we need to get the list of membership types from the database. So var membership types equals context.membership types. Oops, we don't have that DB set here. Let's go to Solution Explorer, open up models, identity models. Here's our application DB context. We need to add a DB set here. Prop DB set of membership type. And we call it membership types. Save. Now we can close this file with Shift and Escape. So context.membership types toList. Okay, now we need to pass this object to the view. One way is to pass it in the view method here, but this approach is not going to work later when we implement editing a customer, because there we also need to pass a customer object to this view. So as I explained in the last section, in situations like that, we create a view model that encapsulates all the data required by this view. So back in Solution Explorer, right-click View Models, add a new class, New Customer View Model. Okay, in this view model, we need a list of membership types. So prop, we can either use the list object here, list of membership type, like this, or we can use IEnumerable. What's the difference? Well, in the view, we don't need any of the functionality provided by the list class, like adding an object, removing an object, accessing an object by index. All we need is a way to iterate over the membership types. So if we use IEnumerable, we get that functionality. Now, if in the future we replace the list with another collection, we don't have to come back and modify this view model, as long as that collection implements IEnumerable. So this way, our code is more loosely coupled. Now, in this view model, we also need properties of our new customer. We can either use the customer type here, or explicitly add its properties like name, birth date, and so on. Which approach should we use? It depends. If you can reuse the existing domain object, that should be your preference. But sometimes, in large, complex applications, how you present an entity on a view can be different from how it's defined in the domain model of your application. In those situations, if you want to reuse the existing entity, you might end up polluting that entity by adding additional properties which are only required by a view. In that case, you really need to separate the domain and view models and let each model evolve independently. But in case of our add customer form, we don't have this scenario, so it's better and easier to reuse this customer entity. Okay, our view model is ready. Now back to our action. We need to initialize it here. View model equals new customer view model. And set membership types here. And then we pass it to the view model. Now let's go back to the view. On top of the view, first we need to change the type of the model for this view. So it's going to be new customer view model. Now you see we have a bunch of errors here because this view model does not have properties like name or birth date. So we need to prefix them with customer. Customer. And we got one more here. Customer. Okay, now to add a drop-down list, I'm going to select this form group, copy, and paste it below the checkbox. Change the label to membership type ID. And then instead of text box 4, I'm going to use drop-down list 4. This drop-down list is for membership type ID property. Now here, as the second argument to this method, we need to supply the list of items for the drop-down list. So we pass new select list. This is one of the types in ASP.NET MVC that we use to initialize a drop-down list. The first argument to the constructor of this class is the list of items. So that's model.membership types. As the second argument, we need to specify the name of the property in membership type class that holds the value for each item. So that's going to be the ID property. The third argument is the property that holds the text for each item. So that's going to be the name property. Now, after this select list, we supply another argument, and I'm going to pass an empty string here. This will add a blank item on top of my drop-down list. Or I can change this to select membership type. And the last argument is the class as before. Now let's compile the application. Ctrl+Shift+B. Back to the browser. Refresh. Okay, here's our drop-down list. So the label is membership type ID, which I'm going to override in a second. And look, this is the first item that is selected by default. And here we have our membership types. Now back to Visual Studio. Let's go to Solution Explorer. In the Models folder, open up the customer class and apply display data annotation on membership type ID property. And here we set the name, membership type. Now to make this code clean and consistent, I would like to add a vertical space between each property, because currently you see all these properties and data annotations mixed together look a little bit ugly. So vertical space, another one, another one. Now you can easily read this code and see what data annotations are applied to what properties. Let's build. Back to the browser, refresh. Okay, membership type ID is changed to membership type. Okay, our form is ready. Now let's add a button and implement saving a customer. So back to our view, scroll down. At the bottom of this view, before this closing curly brace, which is the end of the form, I'm going to add a button. The type of this button should be submit to submit the form. And I'm going to give it a couple of bootstrap classes. btn, which is required by all buttons, and btn-primary, which gives it the color used to represent the primary action used on this view. And we call this save. Now, if you scroll up, you see that earlier when we created this form, we set the name of the target action to create. So let's create this action. Back in the controller, MVC action 4 tab. We call it create. Now we need to apply HTTP post attribute to this action to make sure it can only be called using HTTP post and not HTTP get. As a best practice, if your actions modify data, they should never be accessible via HTTP get. Okay, next I'm going to add a parameter here. Because the model behind our view is of type new customer view model, we can use this type here, and MVC framework will automatically map request data to this object. This is what we call model binding. So MVC framework binds this model to the request data. So let's see model binding in action. I'm going to put a breakpoint here with F9 and run the application in debug mode with F5. Okay, this takes us to our home page. So we should manually go to customers/new. Now right click on an empty area and select inspect. Select network tab here. Now fill out the form. Name is Mosh. Date of birth 1st January 2000. Subscribe to newsletter. I tick that and select the membership type pay as you go. Save. Now go back to browser. In the network tab, you can see our request. Let's click this. Select headers tab here. Scroll down. Let me expand this so you can see more clearly. Look, this is our form data. Customer.name is Mosh, customer.birthdate, and so on. So when this request goes to our application, MVC framework will use these properties to initialize the parameter of our action. Now back to Visual Studio. Here's our parameter. Let's inspect it. Customer. You can see birth date set to 1st of January 2000. Is subscribed is set to true. Membership type ID is 1, but membership type is null because we didn't have a property by that name in form data. Now let's stop the debugger with Shift and F5. Now, if we change the type of this parameter to customer, MVC framework is smart enough to bind this object to form data because all the keys in the form data were prefixed with customer. All right, so this is how model binding works. Next, I'm going to show you how to add this customer to the database. Okay, now to add this customer to the database, first we need to add it to our DB context. So context.customers.add customer. Now, when you add this to the context, it's not written to the database. It's just in the memory. Our DB context has a change tracking mechanism. So anytime you add an object to it, or modify or remove one of its existing objects, it will mark them as added, modified, or deleted. Now, to persist these changes, we need to call context.saveChanges. At this point, our DB context goes through all modified objects, and based on the kind of modification, it will generate SQL statements at runtime, and then it will run them on the database. All these statements are wrapped in a transaction. So either all changes get persisted together or nothing will get persisted. Now finally, we need to redirect the user back to the list of customers. So return. Let's get rid of this breakpoint with F9. Redirect to action. Index in customers controller. Next, I will show you how to implement editing a customer. Okay, here's the list of our customers. Let's click on a customer. So this takes us to customer details page, which is a read-only view of the customer. First, I'm going to replace this with an edit form. So back here, I want to change the link under each customer. Back to Visual Studio. Let's go to Solution Explorer. Open Views, Customers, Index. Okay, here's our action link. So instead of using the details action, I'm going to use edit action. And we're going to create this action in a second. Note the fourth argument of this action link method. We have an anonymous object with a property called ID. So this will be sent to the edit action. Now to create this action with ReSharper, you can put the cursor here, press Alt and enter again. Now here, first we need to get the customer with this ID from the database. So var customer context.customers.single or default. Here you pass a lambda expression. C goes to c.id equals ID. Now, if the given customer exists in the database, it will be returned. Otherwise, we get null. So we need to check for that. If customer equals null, we return HTTP not found, which will give us a standard 404 error. Otherwise, I'm going to use this customer and render the customer form. So return view. Now the view we created earlier is called new. So here we need to overwrite the default convention in MVC and specify the view name. Otherwise, without this, MVC will look for a view called edit. Okay, back here. Now the model behind this view is new customer view model. So let's create a view model. Equals new customer view model. And here we need to set customer to this object. We should also initialize membership types. So we can get it from the database straight here. Membership types to a list. And then we pass this view model to our view. Now, there are a couple of things I don't like about this code. Look at this type, new customer view model. But here we're editing a customer. So let's change this name to a better name. Press F2. And let's change this to customer form view model. Okay, this is a better name both for creating and editing a customer. Another issue I see with this code is the name of this view. Again, we need to change this. So in Solution Explorer, here's the view. Press F2 and change this to customer form. Okay. Now we change this to customer form as well. We should make the same change in the new action. So we can find the action quickly using this drop-down list. New. And here we pass customer form as the view name. Okay, let's test the application. Build. Back to the browser. Refresh. Okay, let's click on one of these customers. Okay, our form is populated with this customer. There is a tiny problem here. Look at this. I don't want to have the time component of datetime to be displayed here. So let me show you how to fix this problem. It's very easy. Back to Visual Studio. Let's go to our customer form. Okay, here's our birth date text box. This text box form method has a few different overloads, and one of them takes a format string. So as the second argument, we can pass a format string, curly brace 0, DMMMYYYY, which is a standard format string in C#. Save. Back to the browser. Refresh. Okay, beautiful. The problem is solved. Also, in terms of aesthetics, I'm not quite happy with this checkbox being between these two text boxes. The form looks a little bit out of balance. So I'm going to move the checkbox at the bottom of the form. Back here. Here's our checkbox. Cut. And paste it after the last form group. Save. Back to the browser. Refresh. Okay, the form looks cleaner and more balanced. Next, I'm going to show you how to update this customer. Okay, now let me show you how to update this customer. So here's our customer form. Note that the target action is set to create. Now here we have two options. We can either rename this target action to save and reuse it both for adding or updating a customer, or we can create another action called update. And here in the view, depending on whether the customer has an ID or not, set the target action dynamically. I'm going to go with the first approach because that's easier to implement. So back in our controller, here's the create action. Put the cursor on the method name and press F2. And then rename this to save. Okay, now back in the view, you can see that when I used F2 to rename this action, ReSharper automatically updated the action name here. If you're not using ReSharper, you need to manually change the target action here. Okay, back in the controller. Now here we need to check if this customer has an ID or not. If the ID equals 0, that means this is a new customer. So we should add it to the database. Otherwise, we should update it. So if customer.id equals 0, that's a new customer. Otherwise, it's an existing customer. Now to update an entity, we need to get it from the database first, so our DB context can track changes in that entity. Then we modify various properties, and finally we call save changes. So var customer in DB context.customers.single customer with ID equals customer.id. Note that I'm using the single method here instead of single or default. So if the given customer is not found, this is going to throw an exception. I don't want to handle the scenario where the given customer is not found, because this action should only be called as a result of posting our customer form. Okay, so here's the customer object in database. Now we need to update its properties based on the values in the form. There are two ways to do this. Our controllers have a method called tryUpdateModel. We can call this method and give it this customer in DB object. With this, the properties of this customer object will be updated based on the key value pairs in request data. This is the approach that you see in official ASP.NET MVC tutorials on Microsoft website. But I personally do not like this approach because it can open up a number of issues. The first one is that it opens up security holes in your application. So in our customer form, currently we are updating all properties of this customer object. But imagine in your application, you don't want the user to update all properties of a given entity. Perhaps only users with special privileges should be able to update all properties. Or maybe some properties should never be changed. Now with this tryUpdateModel, a malicious user can modify request data and add additional key value pairs in form data. And this method will successfully update all properties. Now the workaround that Microsoft shows you is even worse. They say you can whitelist the properties to be updated using the third argument of this method. So, something like this. We provide a string array which includes the name of the properties to be updated. What's the problem with this approach? The problem is these magic strings. If tomorrow you rename one of these properties as part of your code refactorings, this code will break. So the bottom line is you should not blindly read all request data and put that in your objects. That opens up security holes. So what is the alternative approach? Well, instead of using this tryUpdateModel, you can manually set the properties of the customer object here. So customer in DB.name equals customer.name. Duplicate. Birth date. One more time. Membership type ID. And is subscribed to newsletter. Now, if you don't want to set each individual property here, you can use a library like AutoMapper to do this. AutoMapper is a convention-based mapping tool. So it looks at the property names of the source and target types and maps them by convention. So instead of these 4 lines, your code may look like this. Mapper.map customer to customer in DB. So it looks at the properties in customer object and then looks for properties with the same name in the target object and maps them accordingly. Now, to address the security issue that I explained earlier, if you want to limit the properties of the customer that can be updated, instead of accepting a complete customer object here, you can create a different class and call it something like update customer DTO, which stands for data transfer object. So it's a simple data structure, which is a small representation of a customer with only properties that can be updated. And this way, you can safely use a tool like AutoMapper to update all properties in that DTO to your domain object. But that's beyond the scope of what we're doing for now. So let's just revert this back. Okay, so we update the properties of our object. And finally, we call save changes and then redirect the user back to the list of customers. Now, one final step. Here, we are relying on customer.id. But this ID is not currently in our form. We only have input fields for name, date of birth, and a couple more properties. So let's go back to our form. We need to add ID as a hidden field here. And I personally prefer to put that just before the submit button. So this way I know where all my hidden fields are. HTML, hidden for, m goes to m.customer.id. Now let's test everything. Ctrl+Shift+B, back to the browser. I'm going to refresh this page. And then put a plus right here, save. Beautiful, it's updated properly. In the next section, I'm going to show you how to add validation to our customer form. But before we get there, I want you to do an exercise to master what you have learned in this section. So review the cheat sheet in the next lecture and get ready for an exercise. Okay, this is the exercise I want you to do in this section. First, in the list of movies, I want you to add a button on top of the table to create a new movie. And by the way, this is actually a link, but I have applied 2 Bootstrap button classes to make it look like a button. Now, when we click this, we get this form to add a new movie. Here we have 4 fields: name, release date, genre, which is a drop-down list, and number in stock. Note that for release date, genre, and number in stock, I've overridden the labels, because in our model, there is no space between these words. So that's something I want you to do as part of this exercise. Also, for now, assume that all these fields are required. So when testing the application, populate all the fields. In the next section, we'll work on validation. Now let's go back. Next, I want you to modify the link under each movie such that when we click it, we see our movie form populated with that movie. And note that when I'm editing a movie, the heading of the page is changed from new movie to edit movie. And finally, implement update. So make a few changes here, update the movie, and make sure the movie is updated in the database. Now, as part of this exercise, it's possible that you may get an exception like this. So in the next lecture, I talk about what this exception means and how to resolve it. And one last tip. As a good programming practice, instead of solving this exercise in one go, break it down into a few smaller exercises. For example, first, focus purely on adding a new movie. Don't worry about editing. Once you implement the form to create a movie, then focus on editing. So one step at a time. All right, all the best, and I will see you in the next lecture. Okay, as I'm implementing the solution for the exercise in this section, I caught this exception and I thought to dedicate a lecture about what this exception means and how to resolve it. Because this is an exception that you may see from time to time when saving data with Entity Framework. Now, unfortunately, the error message itself does not tell you what the actual source of the problem is. It just tells you the validation failed for one or more entities. And then it guides you to see Entity Validation Errors property for more details. So back in Visual Studio, I got this exception when adding a new movie to the database, right here. Now I'm going to run the application in debug mode using F5. This opens a new tab, which I'm not interested in. So I go back to the other tab, press Ctrl R to refresh, and this will cause a new form resubmission. So I don't have to fill out the form again. Continue. Okay, here we are, we got the exception. Now click View Detail. Expand this exception object. Here's Entity Validation Errors. And you see we currently have one error here. Now, unfortunately, when we expand this, we don't see the errors. So the only way to get access to the errors is to manually add a try-catch block in the code. So close this. Shift and F5 to stop the debugger. I'm going to select this line and surround it with a try-catch block. And then change the type of exception to DB Entity Validation Exception. Now I put a breakpoint here with F9. Run the application in debug mode again with F5. Back to the first tab. Resubmit. This time it doesn't work because we stopped the debugger and now the browser is trying to send a GET request to the save action. So unfortunately, we have to fill out the form again. Okay, here we are. Let's inspect this E object here. Here's Entity Validation Errors. Expand this. Again, validation errors. Unfortunately, you have to expand a few times to get to the actual error. So you see property name, genre, and the error message is the genre field is required. So let me stop the debugger, Shift and F5. So basically what's happening here is that in the movie class, we decorated this genre property with the required attribute. And in the controller, when we get this movie object from the form, its genre property is null, because in the form, we post genre ID, which is the key for our drop-down list. So to solve this issue, we have two choices. We can go back to the movie class and move this required attribute to genre ID. And because these two properties are related, Entity Framework does not see this as a change in the model. So if you create another migration, that migration is going to be empty. Entity Framework is not going to make any changes to your database. Another approach is to go back into controller and before saving the changes, read the genre with the given ID from the database and then set movie the genre here. But this would require an unnecessary call to the database. So I'm going to go with the first approach using the required attribute here. Now in the controller, let's get rid of this try catch block. So if you saw this exception, this is how you solve it. So in this section, you learned how to build forms with ASP.NET MVC. More specifically, you learn about the markup to render modern and responsive forms, how to overwrite labels using display attribute, how to render drop-down lists, and how to add or update data using Entity Framework. In the next section, we're going to add validation to our customer and movie forms. So I will see you in the next section.